So I lied at the end of the last video. Actually, the weekend has passed. I'm back at it and realized that before going on to sort of a brief description of Bayesian inference, I wanted to introduce more on the frequentist side, sort of for contrast purposes later on, and also just to press on because it's the frequentist perspective that will dominate. So we've seen a lot of this before. At standard error of the p hat, SE p hat should be equal. That's a sample proportion, and that's the formula calculated standard error. These are real data for a change. I looked sort of at a Gallup survey, got this off pollster.com, found a Gallup survey in the field. This is 2013. Gallup survey in the field, August 3 to 5. In sample size is 1,500 adults. So all kinds of weighting going on in there, but we're going to assume that it's a simple random sample. We're going to assume incorrectly that it's a simple random sample and not worry about it. P hat equal 44. Gallup's finding in early August that 44% of Americans respond with the word approve when faced with the question, do you approve or disapprove of the job Barack Obama is doing as President of the United States? This is the presidential approval measure. Very, very common. Mentioned before. Previous examples about elections. This was just about the proportion who approve. 44% approve. We translate that to a proportion as 0.44 p hat from Gallup. Similar time frame, August 6th to 8th. Rasmussen, another polling operation, is out in the field, and they're also interviewing 1,500, this time likely voters. So it's always interesting to note and important to note the population or sampling frame where the pollster has sort of dedicated their efforts. You could be interested in likely voters for an empirical reason. Maybe there's an election coming up, and you care more about what likely voters think than you do about adults, which includes the population of non-voters, people who aren't likely to vote. So there's a little bit of difference here in the target, and a little bit of difference in the time frame, and yet a substantial difference if you care about the 50th percentile, and we always do when studying presidential approval or elections for that matter. P hat from the Rasmussen poll is 0.48. They found 48% of likely voters in a similar time frame are approve of the job the president is. And we're going to do something different with this in a subsequent video. But right now I just want to do a real simple hypothesis test with each one. It sort of gets us toward the notion of a p-value. And in the context of introducing Bayesian inference, I want to sort of give you the background on what it is that Bayesians find so problematic about this process. We care, in majoritarian terms, we care normatively about 50% level of approval. We care about it because if fewer than half of Americans approve of the job the president's doing, then it's at least a news story. And journalists report on data like these every day. Some of you are journalism minors, some of you are journalism majors. This is an important talk for you. Do you see these two same numbers, one from a different poll, can produce a headline for a story that's the same. President Obama's approval rating falls below 50%. It had climbed above it by the indicators from most poll outfits during the election season, or right at the end of it. Inauguration comes again, a little happy stuff. Now we're well into President Obama's second term, and a lot of news stories have appeared this summer about his approval rating going down. Sometimes journalists want to introduce that topic with the headlines. President Obama's approval rating falls underneath 50%. As social scientists, that's not really the way we do things. We set things up this way. You've seen this before. We're going to establish for ourselves a null hypothesis that is sort of the flip of what our active or alternative hypothesis might be. So we're going to propose hypothetically that Obama approval has in fact fallen beneath 50%, and the null then is that it hasn't. It's not under 50%. And the null doesn't say much other than that in this case. So we're going to pit one against the other and decide whether we can reject the null, and by doing so, kind of, sort of, embrace the headline from the piece of journalism one of you has written about Obama's approval rating. And we're going to use this thing, and we're going to build a confidence interval. So we're going to do exactly what we did before, sort of taking two standard errors in either direction of the observed p-hats, and we're going to write down a confidence interval for both Gallup and Rasmussen. Now I want you to do this, you're going to have to, test-wise, so you might as well get used to it. It's very, very easy. From Gallup, this is 0.44, and because it's 0.44, we know 1 minus p-hat is 0.56. So you're going to take the product of those two, find the square root, and then find the square root of 1500, divide then this by this, and you'll have one standard error. Now technically it's 1.96 standard errors, but we're going to hold out here and just do things rough and ready, and note that about 95% of the area under the curve, this is normally distributed in repeated sampling. These p-hats are normally distributed, and about 95% of the area under the normal curve is going to fall within plus or minus 2 standard errors of this statistic. And we're going to use that to say something about our confidence that Obama approval rating has fallen under 50%. The Gallup number is 0.44 here, so you work this out. They're going to, this is going to be the same for both, obviously. I believe it's 38.73. These are going to be very nearly identical also for both calculations. Very nearly identical, but not quite. So there are sort of these two different scores, 0.44 and 0.48, in this particular case, are going to produce standard errors really about the same size. In fact, if you round up even one number, they're going to be the same. So what you do then is take 2 times the standard error, and for the Gallup interval, subtract it once from 0.44, and you're going to get 0.1414, and then you also add it and get 0.462, and the interval between 0.414 and 0.462 is said to be your 95% confidence interval. And what that means, we've already discussed. It means that if you sampled over and over and over again, random samples, size 1500, you would expect 95 out of 100 of them to fall inside that interval, and the sampling error be pushed out into the tails of the curve. Probability that you're outside being 0.05. That's a p-value. I'm going to get to that in a subsequent video. So 95% confident that in repeated sampling you do this over and over and over again. So the frequentist can't really say that the probability of p falling inside this interval is equal to 0.95. Can't say that with a straight face because p to the frequentist is fixed. There is a real population parameter, p, and there's not a probability that it falls into or out of an interval. It is fixed, and what you're trying to do is make inferences, essentially in this case around it, and assure yourself with these data that you're not making a mistake in embracing, in a sense, the alternative hypothesis. The alternative hypothesis you don't embrace it here. Your high number is 0.462. No, you do embrace it here. It's the next one you don't. It's 0.462. So 95% in the Gallup, from the Gallup data, 95% of subsequent samples should, in fact, produce something supportive of the headline. The headline being that Obama's approval rating is under 50%. You see then, this is very different. So the low value here in the Rasmussen interval calculated the same way. The low value here is 0.5454. The high value is 0.506. .506 goes, of course, north of 50%. And here your headline then would be not really supported by the data in the context in which social science norms, rightly or wrongly, request that they should be. Because 0.5 itself falls inside the interval. It falls inside the 95% confidence interval. So this is a mistake to do. As a practical matter, I'm going to say at the end, for those who care, a practical matter is to use all the data that you possibly can. And pollster.com is a very good resource for that. They combine estimates from every poll they can find to produce summary estimates. So a better practice really for journalists is to check the aggregated polls and not really focus that much on a single one. I'm going to move now to some more work with proportions in just a subsequent video, once again preparatory to criticism of this approach from Bayesian statisticians.